For today's vocabulary notes, you will need in class 69, that's page 65 in your geometry spiral. We will be starting volume today, so it will be different than surface area, so pay attention to similarities, but also watch out for the differences between these two topics. We will use capital V as the abbreviation for volume, and volume relates to the space that's inside a geometric solid. Where surface area was the area of all of the surfaces, volume is about how much will fit inside a solid. We are going to tackle both right prisms and cylinders within class 69, and both of those have the same volume formula. You will take your capital B and multiply it by capital H. As a reminder, capital H is still the height of the solid. So that means that we are describing the distance between the bases. Capital B is still the area of the base of the solid. And so that means we're going to be using our area formulas from standard 14 again. Lowercase bh, lowercase bh over 2, lowercase ap over 2, or pi r squared. So we'll watch for those to pop back in when we're calculating capital B. To make sure that you remember which of those formulas goes with which type of a base, we are going to fill those in down below. So if you have a rectangular base or a square-shaped base would also apply here. That is when we're going to have a base and a height that are the two sides of the shape connected by a right angle. So that capital B would be found by doing lowercase b times lowercase h. For triangles, we might have a right angle in the triangle itself, which means that our base and our height are located on the sides, or we had some isosceles triangles back in standard 14. That means that that height would be drawn down in between these two sides that are identical, and then this whole side here would still be the base. So for triangles, we're always going to look for those right angles. The base is always a side of the triangle, but the height might be inside the triangle, or if it was an obtuse triangle, it could even be outside the triangle, so that it can make that right angle that we need. Polygons could have 6 sides, but they might also have 5 or 7 or 8 or 9 or 10. This one's a hexagon. We don't usually draw the whole polygon, but you'll be able to see it now because it will be in the picture of the solid. We used to draw that little right triangle there. And that vertical side would be the A. That bottom side would be the X in our pictures. We would find that angle at the middle, which for a hexagon would be 30. The official area formula, though, would be AP over 2. Perimeter was a problem for people, so you might want to remind yourself that perimeter is equal to 2 times that little x, and then also times the number of sides. So for this one, it would be 6 since it's a hexagon. So in this picture, it would be 12 x's that it would take to get to your perimeter. If it had been an octagon, it would have been 16 of these x's, 2 per side and 8 sides all the way around. So finding that perimeter is more than just this distance. Last but not least is our circle. If we draw out from the center of our circle, that's our radius. And so if we have a circular base, that capital B part of the formula will be found with the pi r squared formula from before. If you don't have a highlighter, you might want to grab one real quick because we're going to do a little bit of work on these example pictures. You're going to highlight the base in each of these shapes. And the reason why we're doing that is because if we make a poor choice about what the base of the shape is, then we're going to end up with all kinds of problems when we try to fill in our formula for volume. So if you're dealing with a square prism, that means that the square is the base. It doesn't look like the front is a square because it would be a 5 by 3, that's a rectangle, but it does look like this bottom would be the base because it's 3 by 3. If we're dealing with a triangular prism, the triangle is going to be the base, so I'm actually going to highlight it on the top of the shape, but you could also highlight it down here on the bottom. For number 3, they're telling us that it's hexagonal or hexagonal prism. So that means the hexagon is the base. That's either over here on the left side or over here on the right side. So those would be the base shapes. And then for the last one on this side of the page, it's telling me to look for a pentagon. And so that would be either the top, or we could have shaded the bottom as well. We are going to do just a little bit more work with this vocabulary notes video. If you would flip the page to page 66, you'll see a few more examples of prisms and cylinders. So we're going to continue our work of highlighting the base. This problem says that it is a triangular prism, so that means that the triangle in the front or the triangle in the back or both could be highlighted to represent the base of that prism. Looks like that triangle has one side that's 8, one side that's 12, and then back here another side that's 8. So we'll have to do some work with that later, but an isosceles triangular base for that. The remaining 3 problems are slightly different because they're not prisms, they are cylinders. Cylinders are a little bit more predictable than prisms though, because the circles always act as the bases. So you could highlight the top or the bottom for cylinder for number 6. And then for number 7, our cylinder has actually been turned on its side, and so that left face or right would be the one that we would want to focus on. For number 8, we have a composite figure. Just a second, my lights are going off. There we go, wanted to make sure you could see. A composite figure is going to be a little bit more complicated because it's got multiple solids either stacked together or sometimes, as is the case here, hollowed out. So if we look at this composite figure, we'll have to come up with a game plan to remove that volume that's on the inside of that prism when that cylindrical hole has been removed from the inside. Our last order of business for this video will be to flip back to page 65 one more time, and we're going to tackle one of the level 1 volume problems together so that when you're in class tomorrow we can focus on those problems that are going to be a little bit more difficult in terms of their application. So example number 1 is going to be our focus. We can see that we have a square prism here, and our volume formula from up above for a prism is that V is equal to capital B times capital H. We already highlighted this square shape at the bottom as being our base, so if we're trying to make a list like we did with our surface area problems for the things that we are missing and need to track down, capital B will be first, and then capital H will be second. Since this is a square, our square formula for area is just lowercase b times lowercase h, both of which are equal to 3. So we do a quick 3 times 3, and our base area is 9. Just like with surface area, our capital H is the distance between our bases. So if we start at that yellow highlighted base and we travel up to the one that would match it at the top of that prism, the best place to focus is over here on the left-hand side where that 5 inches is labeled in. That will be our capital H. Since we have both of those tracked down, we can now plug them into our volume formula. So we'll do a quick 9 times 5, and volume will be 45 inches cubed this time. Since we're talking about the space inside this 3-dimensional solid, we're going to stack up cubes inside there to fill up the volume instead of squares like we did with square inches for surface area. Alright, that's it for today. Bring those notes back for tomorrow and we'll jump in with some of the level 2 examples and then cylinders and composite figures on the back.